Hi, if you're interested in my detailed training videos in course format, do visit my profile on udemy.com. The link to the same is in this video description. If you live in India or willing to pay by Indian rupees for my paid training courses, you also have the option to enroll on /prog.com. The link to the same is also in this video description. Hi, in this video, we will learn how to interface the debug file system, writing a kernel module. To tell you about debug file system, I should tell you a little bit about the history of pseudo-filesystems. Till 2.4 kernel, Linux had just one pseudo-file system, which is the proc file system. The proc file system was used not just for exposing process-related information on Linux, but over time, by the time 2.4 was released, lots of information was exposed via /proc that includes not just core kernel information like process related information and core kernel statistics and so on, but a lot of debug related information was also exposed by various driver writers. So if at all I wrote a driver in the early days and I want to expose certain variables from my driver for debugging and diagnostics purposes, so I can see how those variables change from userland, I could expose a file under /proc in the early days. But this led to a big clutter. In fact, the proc file system got cluttered even more with existence of a lot of files and folders representing hardware related data like bus related information, various device subsystem related information, and so on. Even today in the newer Linux kernel, you will see some of those remnants existing because of backward compatibility reasons with userland. Many userland tools and utilities used to use these files which were exposed by the kernel maintainers for building tool chains on top. And some of these tools might still depend on them. That's the reason why in the newer kernel, you will even now find some remnants like things like /proc/acpi, /proc/asound, /proc/bus. These folders are not supposed to be there anymore. There are other alternatives. What happened in 2.6, that is 2.5 kernel onwards, is that they came out with a more cleaner infrastructure to bifurcate different parts of the kernel via different pseudo file systems. For example, they want to keep the proc file system more conservative, where only the core kernel statistics and diagnostics information are exposed in here, and a lot of other components that related to hardware information was moved into another pseudo file system, which we all know today as sysfs, which is mounted under /sys file system. The sysfs became the new pseudo file system that carried forward all the driver and device related data. So all the hardware information you'll find here. For example, look at /sys/bus. You get to know about all the different buses supported on this hardware, right? Running Linux kernel. And you can also look at /sys/devices. Will give you a complete topology of all the hardware devices in a hierarchical manner that are detected by the Linux kernel for which the drivers exist. So this was mostly for hardware related data, but now slowly people started exposing a lot of diagnostics and debugging details via sysfs. So to address this need, to ensure that user space developers don't treat them as a standard API, they introduced something called debug file system. A debug file system is a new pseudo file system driver. When I say new, it has been there from Linux 2.6.30, if I'm not wrong. That's when it was officially made available. So it's been there for a long time now. This particular debug file systems, the official mount point for it is /sys kernel debug. So whatever files and folders that you see here, these are not APIs. These are not to be treated as APIs. It is like telling the user space developers and users, okay, if you build any tools to read these files, over time, the file structure and the file formats can change. So there are chances that the tools written on userland can break. This is just to give flexibility for the kernel developers to instrument their drivers or their subsystems, right? But having said that, there are a couple of folders in here which are still becoming standards. That's the reality, unfortunately. So for example, if you look at /sys kernel debug slab, okay, this folder is empty. They moved this to /sys kernel slab now. And you'll find some things like dynamic debug. When this in the recent version of Linux kernel, I guess in 5.x kernel, maybe 5.1 or 5.4, around that version, they have promoted this from debug file system to make it as a standard kernel ABI, which is now under /proc/dynamic debug. It's promoted. When things become standardized under debug file system, where user space developers wants to use them through the tool chain, they promote them off from debug file system into other locations, maybe /sys kernel directory hierarchy, or it might go to proc file system if necessary. So I'm going to show you how to add a new file in here, create a folder and add a new file under debug file system. In the previous video, the previous example, I told you how to interface proc file system, where we exposed a variable called jiffys. Let's do the same, but this time via debugfs. So for doing that, I'm going to create a folder here in my kernel modules directory. I'm going to create a folder called debugfs example this time. Or maybe I can just call it as debugfs underscore, or you can say jiffys debugfs to make it more intuitive. And in this particular folder, I'm going to create a file, jiffys debugfs.c. And I'm going to create the complete boilerplate using my standard module mechanism. So I'm just going to call it as module name as jiffys debugfs. And the module description as a demonstration. Okay, simple LKM to demonstrate exposing files under debugfs. That's it. Creates that boilerplate. In order to use the debugfs file system, you need to include debugfs.h. So that's a header file that you need to include. So I'm going to include it right here. So I'm just going to use #include linux/debugfs.h. Let me show you that header file. Yeah, I think I have the file open here. Include linux debugfs.h. This particular file, you can see the commentary of that. A tiny little debug file system, initially implemented by Greg Hartman, the maintainer for the stable tree as of now, and by IBM. It was working at IBM, I guess, and debugfs is for people to use instead of /proc or /sys. Suggest this in a single line. And they also talk about lookup documentation /file system for more details. I should also tell you that the debug file system implementation, the file system driver implementation, is very lightweight and simple. In fact, if you want to write your own file system driver, maybe a pseudo file system driver of your own choice for your own purpose on Linux, I think you can just read the implementation of debug file system, right? Source code, and copy it and adapt it to your needs. It's much easier that way. So you'll understand the APIs that you should use to register your own file system drivers. We're not going to be doing that in this particular video, right? For now, we're just going to add new entries in debug file system. The APIs for that are exposed in here. We have a couple of APIs, debugfs attribute, debugfs attribute signed, and there are the new entries in here. Okay, but we're going to use these functions. Your debugfs underscore create file and save. These are low-level functions, rarely used. If you want to create a file that you can do a lot of extra manipulation using file operations, then you can use these APIs. In most cases, for debugging your own driver or any kernel subsystem, you might want to expose a variable so that whenever the variable is being modified in the kernel in user space, you can see what the values are. And the best way to expose them is by using these high-level APIs that you find here. Debugfs underscore create u8, create u16, create u32, u64, ulong, ux8, x16, x32, x64. Now we have features like debugfs create size t if the variable is of type size underscore t, right? Or atomic variables or Boolean variables or even strings. If you want to create a string variable, you can create that. If you want to create your own binary blob, maybe you have a structure and you want to expose a structure in binary format, you can use debugfs underscore create blob, which requires a little more extra boilerplate. Okay, so for now, I will tell you how to expose jiffys, which is a single variable. You're going to expose it via debugfs file system. We can also create folders in it. So there are APIs to create a folder. I guess it's called debugfs underscore create underscore dir. I would have missed it somewhere. There's rename, which will take care of renaming your file. But then you also have create dir. Okay, somewhere down, perhaps. Create file size. Okay, let me just scroll up a bit and search for that. Yeah, debugfs underscore create underscore dir. Missed in the crowd. Okay, you can also get a symlink, or you can create a directory or a regular file in debug file system. So to remove any entry in debug file system, you can use debugfs underscore remove. There's also a macro called debugfs remove recursive, which is now an alias to debugfs remove. It'll remove an entire directory tree, right? If you pass a dentry. Every entry in the debug file system is an instance of a dentry structure. You can see a struct dentry here. It's an instance of the structure. The dentry structure could have been defined right on top. This is not very different than the proc dentry structure that we saw in proc file system. The dentry structure, however, must be defined maybe in another header file. It's not in this. It's a generic structure, I guess. So let me maybe I can just look up the structure by doing a cscope lookup here. Yeah, the word dentry is so common, so you'll find it in many places. All right. Okay, sometimes looking for a generic name, it's cumbersome. All right, maybe it should be there in debugfs underscore param.h or something. Let me just check. Let me see if it's there in fs.h. Yeah, there is a dent. I'm not sure if it's the same dentry structure that is what is used by debug file system. There's a dentry structure used by VFS, which could be very different than the dentry structure that we know of in debug file system. But that structure is very similar to the proc dentry structure. Okay, we will search it later. So I think I don't want to waste time. You should be able to search through this, right? But anyways, so coming back here, I told you, if I want to create a file under debug file system, 1 minute, let me just come back here. So I'm going to be using debugfs underscore create underscore u64. We'll use that for exposing the jiffys variable. And to remove that file, we can also use debugfs underscore remove. We'll also create a folder by using debugfs underscore create underscore dir. And the code here. So I'll use jiffys.h. These are two more header files I'm going to include specific to the use case. To expose a file using debug file system, all you can do is I can just directly say debugfs underscore. First, I'll do debugfs create underscore dir. Okay, create dir of. I can provide the directory name. The directory name I'll call it as jiffys. Under which folder? Null. It's very similar to proc nkdir API. Folder name, under which folder? Leave it as null to create in the top level directory. Even here, you don't want to inject a file into any existing folders under sys kernel debug, which you don't own. That's the reason why they don't provide a simple API to add files into any arbitrary directories. You need to have a pointer to the dentry, which you will not get easily in your code, right? So I'll call debugfs underscore create dir. This returns a dentry pointer. So let me just use that. Dentry star. And then I can use debugfs underscore create underscore, because I want to expose a 64-bit unsigned integer. So I can use u64. The U series of functions, the one with suffix U64, U32, U16, and U8, when they expose a number, they expose as a file, so that when you read it, you get as a decimal number in decimal number system. But the variants which have X series, X8, X16, X32, X64, when you read them, you get the values in hexadecimal. That is the only difference. So whether you want to expose it as hexadecimal values or decimal values, you can choose according to your liking. So in this case, I want to use decimal numbers because it's not some pointers. Only mostly people treat memory addresses in hexadecimal or some mode bits and something. So, but I will use just U64 here. And then the file name that I want to, the U64, if you just look at the API for it, they take four parameters: the name of the file to expose as, the mode bits, then the folder in which you want to add those files, and the address of the variable whose value is to be exposed directly. No callbacks, show function, sequence API is required. That's what makes interfacing with debug file system very straightforward and simple. Just one liner. Okay, just watch me do this. So the file name, I want to call it as value under GPs. And what is the second parameter? Okay, you know, I'm not my memory is very weak. I think it's like you say the name, mode, parent, value. Okay, name, mode, parent, value. So mode bits, I can pass octal number like say 0, 6, 4, 4. 6, 4, 4, right? Actually, when you expose it like this, you can also modify the variable. I will leave it as 444 for now. Okay, for GPs, it's a very bad idea to expose it for writability. I'll leave it as 444. Then under which folder? Under the directory called GPs. And then what else? The last parameter is the address of the variable, right? The address of variable is address of GPs underscore 64. Hope I am correct. Just go back and check under gps.h whether the variable is named like that. So that's the verification I can do. Go back to another terminal and open up include Linux gps.h from the kernel sources. Remember, I just showed you this file, right? And you can see the actual file name is called gps underscore 64. You can directly use this file. I'm running on 64-bit architecture, so I'm not going to use get gp64. Directly I'm using gp64, okay? Exposing that variable as it is. Because you're not like copying the variable content or anything, or exposing a variable, it's okay to access it directly without having to worry about using get gp64. So that's it, I guess. 1, 2, 3, 4. 4 arguments, right? So let me just confirm. 4 arguments. We have the name, mode bits, parent directory, and the value. That's it for U64. This is what I do in here. And in the early versions of Linux kernel, debugfs underscore create APIs like create U64, X64, and all of them, they used to return a dentry pointer. So you get the dentry pointer and store in a global variable that you can remove in the exit code path. Now they've deprecated it. That structure is deprecated. They've changed the structure. So all the create series of APIs are void functions now to make things more simpler, right? So if at all I want to remove this directed tree completely from the exit code path, I can do that simply by using a new API, debugfs lookup and remove of the entry called GPs. Now, this will look up a directory by name GPs and remove the entire tree. In the early versions of Linux kernel, I guess in the 5.x or maybe late 4.x, you used to call debugfs underscore remove of debugfs underscore lookup of GPs. Or you get the dentry pointer in a global variable and you can call debugfs underscore remove of the dentry pointer. The debug underscore remove takes a dentry pointer. So that's one thing. So you can use lookup and remove, which will make it more convenient. So you don't have to worry about extra boilerplate. So this is what makes the code simpler. And I will also expose one more variable. What I'll do here is I'll create another variable here. Maybe I'll just create a, a 32-bit variable, maybe u32, and just create a variable called, let's call this as count. And I'll set the variable value to 1, 2, 3, a simple variable. And I'll also expose this variable here under the same folder with u32 under the name called count. This time I'm going to give the permissions as 644, provide read-write permissions for the user, right? And the variable I want to expose of here obviously is count, so I'm just going to change that here. And yes, return 0. You can see that it's very simple to expose simple integral variables by Debugfs. Just use Debugfs create series of functions to expose them, and then you can just remove it in your module unload path by using Debugfs lookup and remove, and entire tree is removed. So this is what makes interfacing Debugfs file system very, very simple and straightforward. Don't have to worry about sequence file API and using show function, using seqprintf. None of those nuances are required. If you really want to have your own callbacks to be invoked for read, you can use a low-level API which introduces more boilerplate. You have to deal with file operation structure and so on, but generally that is not recommended. The main purpose for using Debugfs file system is for simply exposing integral variables to user land as files, so user space can see as and when those variables change or update. Okay, so I made this change, and that's it. So let me just save this file. Before I exit, I'll also add one more entry here. I'll add a small PR notice before I remove it. Count is equal to, and I'm going to print the value of count. That's it. Because I've given write permission for count, if I modify the count variable, I want to print what the value is, and I'm unloading the module. So you know that whether I'm able to modify a variable from userland. I just created the make file by using the mk command twice, as usual. I'll run make to build this. It's compiled. Now if I do a ls/sys/kernel/debug, these are the folders and files that you right now see. There's no folder called gfs, right? After I2C, I have kprobes. Now, if I load this module, insmod gfs debugfs.ko. Now, if I just look up again, /sys/kernel debug, as you can see, there's a new folder called gfs that comes up because I use debugfs create dir that exposes this as a folder under debug file system. If I now see what's inside this folder, there should be two files because I use two entries in there. Count and value. First, let's look at value, which is the value of gfs, of course. It just sort of exposes the variable directly. As you can keep catting this file, you can see the new value of the variable as it's getting updated. You can see that. So this is how you can expose any kernel variable via debug file system. Just use debugfs_create_u or x suffixed functions, And they take 4 arguments: the file name, the mode bits. Mostly, if you're doubtful, you can just put 0444, provide read access, or 400 if you want to be more paranoid about security. And then you can also specify under which folder you want to expose, or leave it to null if you want to expose it in the top level directory, and the value of the variable's address of the variable. So you can see the value. This value is apparently, if you look at the contents again, use ls minus l. You can see the count is got read write for user, but value is got only read, no read write permission. Now, if at all I try doing a cat of count, sorry, you can see the value 123, which I sort of initialized. If I want to change this value, I can try changing it to echo 456 greater than count. And you know what? The value of the variable in the kernel got updated. I was able to change the value. If I want to verify that, I'll know that when I unload the module. That's where I'm printing the variable from within the kernel, right? So if I run rmmod and debugfs, okay, gfs underscore debugfs, and run dmessage, which will show up the kernel log buffer. These are the old messages from the older code I demonstrated on /proc interface, right? So you can ignore that. You can see that right here. gfs debugfs underscore exit, count is equal to 456. So I can expose a kernel variable, which are primarily integers, to user land, such that you can also allow modification. I can allow that variables to be tweaked, the values of the variables to be tweaked from within user space. Most useful for debugging and diagnostics. So this is a use case. But you might ask me, what happens if I actually make gfs writable? I want you to try it out. What I want you to try out is try and make gfs writable, and try changing the value of gfs, and let me know if your virtual machine survives long enough. In reality, if you update gfs is a common global variable used by various subsystems. Your entire kernel, from my experience I've seen, becomes a little unstable and erratic the moment you update gfs to some value, especially if you make it a smaller number, right? If you make it a larger number than what the current value is, I don't think there'll be a big problem. But if you make it a smaller number, I started seeing the file system driver when I was using ext3, ext4 file system drivers. They used to crash eventually. But I guess all of these subsystems try to take gfs and try to do some math for instrumenting, timing, and all that. So they all fail. So it's suggested that you don't update variables like this, which you don't know about. That's why I made it read only. So if you try to modify, if I try to load this module again, when I unload the module, obviously you can see that /sys kernel debug. You'll see the gfs folder, the entire directory is removed. The debugfs lookup and remove is a very convenient function to remove the entire directory tree under debug file system. You can also provide a file or a folder there, right? And if I load this module again, if I just do a gfs underscore debugfs.kv, load this module, and then if I try to write to, if I can, okay, I use echo command, right? I'll try to write to gfs value. It won't work because obviously I've not exposed it with write permission. So this is what you should know about debug file system. To tell you the truth, I just gave you one simple use case for debug file system where I exposed one existing variable and a variable that I created and created a folder and exposed them as files there. But there are many interesting possibilities with debug file system, like exposing a data structure using a blob mechanism. To know how to use all those APIs, the best way to look up is the kernel samples. I am not sure if it's still there, but let me just verify. In the kernel source code, there used to be a samples, readily available samples for using debug file system. You'll find them in samples folder. Okay, it's missing now. It's no longer there. Earlier, this used to exist. but maybe you should look up at documentation, let's say. Under documentation file systems, there's something called debug fs.rst. There's a real documentation that you find in relation to debug file system in here. They tell you how to mount it manually if you want to, how to create a directory. There's a nice standard API documentation for the debug file system. Creating a file with size and useful functions, but they're covered in here. And look through them. In the very early version of Linux kernel, I guess from you go to 2.6.30 or so on, there was a sample. Let me just check if I go to the mainline kernel tree and travel back in time there. So this is the, no. Hope there's a mainline kernel tree. Yeah, it is. Let me just go back to, let me travel back in time. Git check out 2.6.34. You go to samples folder. It's not even here. Okay, maybe I got the samples elsewhere. Let me check. Nope. I think I'm not sure where I got these samples earlier. So there used to be samples for leveraging debug file system. Maybe I looked up in linuxweeklynews.net website or maybe elsewhere. So there are different examples for exposing a number, exposing a blob and all that. It's same as what I showed you. Okay. But anyways, if you want to learn how to use it, one of the other ways is to find out how others are using it. If you want to use debugfs_create blob, for example, one way to find out is, as usual, the kernel source is your friend, right? So you can use cscope and just look for functions calling this function. Which one? Debugfs_create_. I can see them in many places here. kdebugfs.c. Boot params kdebugfs init, create blob data, and so on. So let's see what this does. Here's how it is done. Create blob of data under boot params, which you can see here. Boot params blob. You need to create a blob structure. You can see it here. You can have any data structure, any buffer. Just create a blob wrapper, debugfs blob wrapper. Name of the variable is equal to data. It will be a pointer to your structure, pointer to any arbitrary structure. And this next member is size, which will be size of that buffer or data structure. Just create that. And then you can use debugfs create blob to expose the raw binary data to user space. In user space, you can instrument by writing some code in user space, which can read it into a C structure again and manipulate it, right? So we do it. So there are a lot of examples for you to look up and learn, right? So with this, I conclude this video on interfacing with debug file system. I hope you learned how to expose debugging information in debug file system via exposing variables using simple API. And this is completely different than proc file system. It's used for different use case, right? I would recommend using proc file system to implement your own custom application binary interface. If you're adding some new interesting core kernel subsystems or interesting statistical features for your driver stack or driver subsystem, maybe you can expose via proc. But for all debugging and diagnostics information, I recommend you use debug file system, right? The other things that you can also explore and look up is sysfs attributes, though it is used by device drivers. So if you were writing your own driver or device driver, use sysfs attributes to expose custom attributes under sysfs directory tree. I will be covering that in another training course on Linux device drivers, right? So with this, I conclude this video. If you have any questions or doubts, feel free to reach out to me in the shared contact details. Thank you very much.